Okay, so basically last week when we went over this screen, these are still the same steps that we're going to kind of go through when we are factoring the problems from today. So you still want to check, you know, the descending order thing and greatest common factor. And then these 3 in the middle, 2, 3, and 4 are kind of special cases. So kind of like shortcuts, I guess you can use to factor certain types. And then the last step is the one that you would use, like, I guess, in a more general way for most problems. It'll work for all of them, but it will, some of them you can only do that. There won't be like special steps in the middle here like you could take. So this is posted on Teams. So if you need access to this file, then it's on last week's like pile of things. Okay, so close that. So this was the first problem that I got from IXL when I typed in code CSS. So I'm gonna screenshot that. Okay, so this is IXL Code CSS, and this is for homework number 7. So this is the first topic out of 2. So the first thing I'd want to check for is there a greatest common factor? And my eyes are probably a little bit, it's easier for me to see it probably just because I have done so many problems, but there is a K in common to both here. So the first thing I would need to do is take out that greatest common factor, which is just K. So I'm going to factor out a K, and that leaves behind K minus 11. So that's factoring. So this was my first step for the problem, which was to factor this all the way, which I did. I can't break it down any more than that, right? So now I have these 2 things. So this is step 1. Now step 2 is going to be to take this factoring here after I'm finished and use the 0 product property to solve for whatever the variable is. So X usually, like in worksheets typically, but on IXL, they do a pretty good job of switching it up quite a bit. So I would literally just do exactly what I did last week. You're saying something times something. So if I'm looking at what I wrote in here on red, something K times something, K minus 11 equals 0. So one of these somethings here has to be a 0, because the only way to do something times something to equal 0 is if one of the numbers is a 0. So you're really saying that either K is 0 or K minus 11 is 0. One of them has to equal a 0 in order for this answer here to be 0. And this obviously is solved for K, so I'm good on this one. This I need to...
Wouldn't it be negative 11 and not positive 11 though?
For the answer?
For K equals, because how
like
do you
this?
get that positive 11?
Because you're literally just solving this, solve like linear. It's just like a linear situation where you're saying if K minus 11 equals 0, then I need to do the opposite of the minus 11 to get rid of it. And the opposite of this minus negative 11 is to add it or do a positive 11.
All right, thank you.
Sure, of course. So it's like you're just moving it over to the other side. So it works just like linear stuff that way. Let's do another example.
Wait, there's only one answer. So which one do we put?
Oh, there you go. So if good, very good question. Good paying attention. If you look at the instructions, and I noticed this for some of the other topics, that they give really specific information about what to do in certain situations. So it does say if you have multiple solutions, separate them with a comma. So good. Thanks for asking that. That's a good thing to point out. So you'd put in a 0, comma 11. Okay, let's see what's next. So let's try that to make sure it works. 0, comma 11. All right, this next example is pretty similar. I'm going to jump forward so we can see something that's a little bit bigger. Okay, this one looks at least harder. All right, so again, I want to check for greatest common factor. So if I go through and look at this, it looks like I definitely have an X in common. And then I can check to make sure 29 and 10 don't have anything, which they don't. So greatest common factor would just be that x. So I can take out x. 29 x minus 10 equals 0. And then just like last time, either x equals 0 or 29 x minus 10 equals 0, which is hopefully you can kind of tell this is going to give you a little bit of a, you know, a larger looking fraction, but it's not any different than what we did last time. I just need to isolate this x. So I'm going to add 10. And then I'm going to divide by 29. And the nice thing with leaving something as a fraction is you don't have to do anything after this except reduce it, which 10 over 29 doesn't reduce. It's the same way that I didn't have a greatest common factor here. The only thing here is a 1 is because that's the same reason that this doesn't reduce. So it's definitely a very like, they're very related ideas, fractions and net factoring and all that. So this is one of my solutions, 10 over 29, and then 0 is my other solution. So I'm going to go back then to the type in answers part and make sure 0. Oh, yeah, 0. Make sure I'm remembering what I'm doing. Sometimes I'm talking and then not even paying attention to what I'm writing down. 10 over 29. So 0 and 10 over 29, which I just type in as a fraction. So this one is actually, again, a very similar type of problem here, where you're going to take n out, it looks like, you know, and then you'll end up with these two factors that don't have anything in common. So I'm already up to 60 at this point.
I have a question.
Absolutely. Go ahead.
Will 0 always be a solution?
No, just a coincidence. I will say, though, when you're starting this, a lot of times they do give you solutions like that just because it's easier for you. This is one where
Okay,
0
thank
won't be, though. So let's do this one. This is at 72. So this is considered one of the more challenging ones. Again, I would take out a greatest common factor first, which I do have one here, right? I can take out a 7. So if I pull out 7 to the front, I have n squared plus 11n plus 10. And so finally now, I will say if I was doing this as a worksheet, I probably would have given you more practice with problems like this. So maybe we'll try to find a topic that has more of this, because I think this is where the good practice is now you have to factor using that product and sum idea. So that's how all of this, it kind of gets tied together, is if I'm looking through all of this, if I'm saying it has to have a product of 10 and a sum of 11, I'm looking for two numbers that multiply to be 10 and add to be 11. And so hopefully you've practiced enough that you can kind of find those right away. And then this is one of the ones, because I have a coefficient of 1 in front, I can use the shortcut, which is just to take my two binomials and fill in the variable at the beginning of each, and then fill in these two numbers inside. Which means that this is what I end up with once I have factored it. So this is factored all the way now. And so now if I solve, I have to set the factors equal to 0. If you're thinking about it, you have three different things here. You have 7, and you have n plus 1, and you have n plus 10. And when you multiply them, it equals 0. So one of these has to be 0. So I guess you would say, you know, you start and set each one equal to 0. Hopefully, though, you can tell this doesn't make sense, right? Because 7 is not 0. So it does mean that one of these two here, one of these has to be 0. So this one is not going to be a 0 because it isn't 0, it's 7. So either n plus 1 equals 0 or n plus 10 equals 0. And so then I would subtract, and I'd end up with my answer as n equals -1 or n equals -10. Okay, I'm gonna do one more, just because this is one of those special cases, so it seems like a good one to remind you of. So this one has only 2 terms. And so if we're thinking of that chart that I put up at the beginning, this would definitely be one of those ones in the 3 in the middle. And it does have perfect squares. So I can't factor anything out this time. There is no greatest common factor. But there is a special case. So this is the difference of squares case. And so the shortcut for that is I can set up my two binomials and I take the square root of the first term. So the square root of 16v squared is 4v. And then I do the same thing with the second term. I take the square root of that 9, which is 3. And then the signs in the middle for this shortcut are opposite. So one positive, one negative, and it doesn't matter which order you put it in. So now so this is the factoring part. So this equals 0. So now this is factored. And so the next thing I need to do then is to solve. So I need to take each one of these factors and solve. And so I end up with similar answers, right? So 4v plus 3 equals 0. So if I subtract 3 from each side, 4v equals -3. And then I divide by 4, so -3/4. And so then the other side, 4v minus 3, means that I would be adding 3 to each side at the beginning. So it really just means I have a positive. So sometimes you definitely get this kind of situation too, where you have answers that are oddly like related to each other, where they seem like, you know, kind of the same number, but opposite somehow.
Will there ever be a time where the last number doesn't equal 0?
No, it's always set up to equal 0. Good question. The reason it's set up, and that actually is a good segue to, this is a perfect square also, just if you're looking at my screen. This is a good segue to talk about what these numbers mean, because so Carlos's question here is will it ever be like not equal to 0 at the end? And the reason it's equal to 0 is because basically what you're saying here is that y equals 0. And if you think about on a graph, if you think about points where y equals 0, those are points that are along the x-axis, right? All of these points would have some number with 0 next to it. And what we're really solving for is where does this equation cross the x-axis? So when I say -3/4 and +3/4, then what I'm saying is that I have a solution here at -3/4 and a solution here at +3/4. So I'm going to have some kind of parabola shape, that curved bowl shape that probably looks something like that. Make sense? Great question. I feel like you guys have practiced all of these skills quite a bit in the last few weeks, so hopefully you're feeling okay about it. But definitely, I would say tomorrow's a good time to get some asynchronous help. If not, I'm going to stop recording.